Section 2.7, Linear Inequalities and Absolute Value Inequalities. In this section, you're going to learn how to use interval notation. You're going to learn how to solve inequalities in one variable algebraically. You're going to solve absolute value inequalities. Here are some examples to review the interval notation concept. Use interval notation to indicate all real numbers greater than or equal to -2. The easiest way to do this is to represent this on a number line or graph it on a number line, an open number line. So here is my open number line, which means it doesn't have any numbers. We're going to put -2 on any spot. I'm going to put it right here. And the question here says we need to represent all of the real numbers greater than or equal to -2. So in order to indicate the inclusion of -2, I'm going to put a closed circle on it, which is going to represent inclusion. Now, greater than means I have to move to the right because all of the numbers to the right of -2 are bigger or greater than -2. Now, here is my interval that I'm looking for, the one that I highlighted. In order to represent this, we're going to begin scanning from left to right. As you can see here, the first number we can see is -2, and -2 is included, so we're going to indicate that with a bracket, like that. And then we're going to say comma, and this interval does not have an end. It goes infinity. It goes to positive infinity, so we're going to say it goes all the way to positive infinity, and since positive infinity is a known, we always say an open parentheses here, so we indicate the openness of the positive infinity with a parentheses. So the answer is going to be from -2 all the way to positive infinity, like that. Number 2, use interval notation to indicate all real numbers between and including -3 and -5. So between and including -3 and -5, I'm going to remove this number line, and I'm going to begin with a new one. So here is the open number line. The smaller number here is -3, so it goes here, and it says it's included, so we're going to put a closed circle at -3. 5 is bigger, so it goes to the right of -3, and it is also included, which means we're going to include a closed circle. Now the interval notation, so we need all of the numbers in between them, which means this interval right here. The interval notation here is going to begin from -3, and because of that closed circle, we're going to include a bracket, and the end is a bracket as well. So the beginning is at -3, and it goes all the way to 5, so comma 5. 3, express all real numbers less than -2, less than -2, or greater than or equal to 3 in an interval notation. Again, I'm going to do that on the open number line. Here is the open number line. Now the smaller number is -2, so -2 goes to the left, and it's just less than, it's not included, so we're going to include an open circle and -2. Greater than or equal to 3, 3 is bigger, so it goes to the right, and it is included, so we're going to include a closed circle. Now, less than -2, that means we're going to begin from -2, and less than means we're going to move to the left because all of the numbers to the left of -2 are less than. Greater than or equal to 3, that means we're going to begin from 3, and we're going to move to the right because all of the real numbers that are greater than 3 happen to be to the right. Now, the interval is going to be this piece, union that piece. So it's going to be 2 intervals and a union sign in between them. The first interval, we begin reading from left to right always, so we're going to go in this direction. It begins from -infinity, comes from -infinity, so -infinity is open. We're going to include parentheses there. And then it goes all the way to -2. It stops at -2, but -2 is not included, so we're going to put open parentheses as well. Union. The other interval, so we're going to begin reading from left to right again. The other interval starts from 3, and the 3 is included because of the closed circle, so we're going to put a bracket. and it goes all the way to positive infinity because it does not have an end here, and infinity is open because, again, we do not know what infinity is. We don't know what infinity is, so we take an open, we represent that with an open parentheses. Number 4, we're going to solve some linear inequalities. Solving linear inequalities is similar to solving linear equations. The only concept that you have to take care of or pay attention to is when you are multiplying or dividing with a negative number. So if the solving process involves multiplication or division, you have to pause and think and ask yourself, am I multiplying or dividing with a negative number? If the answer is right, if the answer is yes, then you have to, if the answer is yes, then you have to flip the inequality sign. Why is that? Because let's say you have 2 and 2 is less than 3. We know that is a fact. Now, if you multiply both sides by negative, if you have -2 and -3 here, you can no longer say that -2 is less than -3 because that is false. So you have to say -2 is greater than -3. So the concept of numbers flips when you multiply with negative. For example, when we say 10 and 8, we know that 10 is bigger than 8. However, if you ask me -10 and -8, you're going to say, well, -10 is the smaller one and -8 is the bigger one. So the concept just flips. I hope that makes sense. Okay, so same here. We're going to begin with the first one, 4x plus 7 greater than or equal to 2x minus 3. So I'm going to gather all of the x terms to one side, and I will put all of the numbers to the other side of the inequality sign. So I'm going to subtract 2x from both sides of the equation. What we get is 4x minus 2x is 2x plus 7 is greater than or equal to -3. Don't forget that negative sign. Now I need to remove the 7 from the left-hand side. So I'm going to subtract 7 from both sides of the equation. What I get 2x is greater than or equal to -10. Now I'm going to divide by 2. I will divide both sides of the inequality by 2. Now, because the division is with a positive number, nothing is going to change. So now I have x is greater than or equal to -10 divided by 2 is 5. If you put that on a number line, or if you know how to do it in an interval notation, the final answer is going to be from -5. It's going to be from -5 all the way to positive infinity. If you're in doubt, just graph it. The second one, 13 minus 7x is greater than or equal to 10x minus 4. Now, I'm going to be a little bit strategic here, and I want to show you how to deal with the x when the inequality is flipped. So, I'm going to subtract 10 from both sides of the equation, just to show you the concept of flipping. So now what we have 13 minus 17x is greater than or equal to -4. Now I want to remove this 13 from the left-hand side, so I'm going to subtract 13 from both sides of the inequality. What I get is -17x is greater than or equal to -17. I'm going to divide both sides by -17. Now the flipping is going to happen in the next step. Okay, because I divided with a negative number here, I will have x is less than or equal to 1. Now, the interval that represents that number is from -infinity all the way to 1, and the 1 is closed. So x is less than or equal to 1. That means the greater value is 1, and anything less than that is in the solution. Solving a compound inequality. Compound inequality is usually an inequality with more than 2 sides. So it has 3 sides. Usually the variable term is going to be in the middle, And then there could be some variable terms to the right, variable terms to the left, or sometimes just numbers like this one. So how do we solve compound inequality? If you see something like this with two inequality signs, how would you solve it? The first method is to break it down into two separate inequalities and then solve them individually and then combine them at the end, or combine the answer at the end. What I mean is, first you're going to focus on, let's say, the left side of the inequality, this side right here. So you're going to write in your inequality like this, which is, if you read it from the variable side, which is the way you should read inequalities, you're going to say 2x plus 2 is greater than or equal to 3. Okay. So if you solve that, you're following the steps. You're going to subtract 2 from both sides of the equation. You're going to end up with 2x is greater than 1. And then you're going to divide both sides by 2. You're going to get x is greater than or equal to 1/2. And then you're going to focus on the other side of the inequality, which is this side. And that is the inequality. 2x plus 2 is less than 6. And then you're going to solve it. You're going to first subtract 2 from both sides of the inequality. You get 2x is less than 4. And then you're going to divide both sides by 2. You end up with x is less than 2. And then basically you don't have to combine it, because this last step is sometimes a little bit tricky for somebody who's not doing this for some time. So if you practice, it will be easy to come up with this idea. However, if you want to find the solution without putting it together like that, you can basically put that on the number line. So you're going to say I have 1/2 and 2. 1/2 is here and 2 is bigger, so it's going to be to the right. The 1/2 is included because of that equal sign right there, so I'm going to include a closed circle. And the 2 is excluded because there is no equal sign, so it's going to be an open circle. This interval is read x is greater than 1/2. Now, if you can't read it like this, just flip it. So we write the x to the left, and then the opening is towards the x. We're going to keep it towards the x, and then 1/2. Now you can read it. X is greater than or equal to 1/2. Because less than looks like an L. So you know the difference. But if the x is on the right, sometimes it's tricky to read. So greater than means we're going to start from 1/2 and go all the way to the right. The other inequality says x is less than 2, so we're going to start from 2 and go all the way to the left. The intersection between the two, this area, is going to represent the inequality. Now, if I look at this inequality, it represents that interval. So this highlighted region is going to be the interval or the answer or the solution for the inequality. Now, if I represent this in an interval notation, I will begin from left. The interval starts at 1/2, and 1/2 is included because of the closed circle. So I will put a square bracket and 1/2, and it goes all the way to 2, and the 2 is excluded, so parentheses there. That's exactly the answer you get here. The other method is to leave the compound inequality intact and perform solving procedures on all 3 parts at the same time. Meaning, the steps are here, but I would like to redo that again. We have 2x plus 2, we read it always from the middle, greater than or equal to 3, and less than 6. So we begin from the variable side, go to the left, and then go to the right. Now, what I mean by working on all 3 sides altogether, we're going to begin by eliminating the 2, so I will subtract 2 from all parts of the inequality. We will end up with 2x in the middle is greater than or equal to 3 minus 2 is 1, less than 6 minus 2 is 4. Now we're going to divide. We divide by 2, we divide by 2, we divide by 2. Again, division is by a positive number, so the inequality sign is not going to change. So we have x in the middle is greater than or equal to 1/2, and it's less than 2. And you can represent that on the number line, or you could basically say, this is an obvious interval. It starts at 1/2, it's included, and the 2 is excluded. So a bracket towards a bracket on the side of 1/2 and parentheses on the side of 2. The next page is going to show you a review of interval notation. Please look at this because it's a prerequisite for the interval notations. You should know how to translate from words to set builder notation to an interval notation. And this is a very helpful list, so please read through it, and if you have any questions, let me know. We're going to move on to the next concept, which is absolute value inequalities. The absolute value inequalities are going to be solved the same way we solve absolute value equations. However, there is one little thing that I want you to remember, which is the concept of flipping the inequality sign when you divide with a negative number, which is in this case basically when we split the inequality into two. What I mean by that is, let's say we have the absolute value of x is less than k. When this was an equation, we split that into two and we said x is equal to k, x is equal to negative k. So that's what we said. This is an inequality. So when we split it, the first half, we're just going to drop the absolute value bars. And we're going to say x is less than k. So I did nothing here except for dropping the bars. The other half is going to be x is greater than negative k, because I multiplied here with the negative number. I have to flip the inequality. So notice that change happening there. Okay. Same if you have x, absolute value of x is greater than k. We're going to split it into two. So the first half is going to be x is greater than k. We did nothing but dropped the absolute value bars. The second half, we're going to keep the expression inside of the absolute value intact. We're going to flip the inequality sign and then change the sign of the right-hand side of the inequality. So in this case, the procedure is going to be keep, flip, and change. Remember, keep what's inside of the bars, flip the inequality, and change the sign of the right-hand side. Everything what I said now is going to be the same in the case you have less than or equal to, greater than or equal to. So whatever is applied to less than and greater than is going to be applied to less than or equal to and greater than or equal to.